Find in polar form the exact solutions to the equation z to the 4 is 2 root 3 plus 2i. So 2 root 3 plus 2i. We'd like that to be in polar form. So it's going to be here, such that this is 2 root 3 and this is 2. So the modulus is going to be the square root of 2 squared plus 2 root 3 squared, which is root 4. Add 4 times 3, which is 12, so that's root 16, so that's 4. And then the angle here is going to be the inverse tangent of 2 over 2 root 3, which is the inverse tangent of 1 over root 3. So that's pi by 6 radians. So we have z to the 4 is equal to 4 cis pi by 6 plus 2n pi. So using Demois, z is going to be, so we want the 4th root of 4. Well, the square root of 4 is 2, and then square rooting again, that's root 2. So that's going to be root 2. And this will be pi by 24 plus 2n pi divided by 4, which is n pi by 2. So, if we take n is equal to 0, we're going to get root 2 cis pi by 24. Take n equal to 1, and we're going to get root 2 cis pi by 24 plus pi by 2, so that's plus 12 pi by 24, which is root 2 cis 13 pi by 24. Now if we go to n equals 2, that's going to put us outside of our principal argument range, so let's try n equals negative 1. So that will be root 2 cis pi by 24, take away 12 pi by 24. So that's root 2 cis negative 11 pi by 24. And then n equals negative 2 gives us root 2 cis, and it's going to be this one, take away another 12 pi by 24, so that will be negative 23 pi by 24. And we could give them in order of increasing angle size if we want. So that's going to be root 2 cis negative 23 pi by 24, and z2 would be root 2 cis negative 11 pi by 24, and then z3 is going to be root 2 cis pi by 24, and finally z4 is root 2 cis 13 pi by 24. So we want to display these on here. Now note root 2. So root 2 is about 1.4. So we're going to want these to be on a circle of radius approximately 1.4. So I've put a circle on here to act as a guide. Now our first one is at pi by 24, and we've discussed this grid before. We know that these are at pi by 12 intervals. So pi by 24 is just going to be half of that first one. Now rather than working out the others, we've got 4 roots here, so we know they're going to be 90 degrees apart. So we're going to have one just here. Then we're going to have one directly opposite that. Now I've made that one over there the wrong length. It's got to land on the circle. So that's going to go there. and then the final one's going to go directly across from this one here. So, like so. And we're representing them as vectors. And so let's have a look. Z1 is this first one, as I've labelled it. This one's Z2, this one's Z3, and this one up here is Z4.